Okay, so let's finish up 6.3. So here's number 5. Let's look again at this number 5. There's a million words here, isn't there? It might be easier, it might be helpful to break it and make it into a table. Some of these, they give you a nice table. Let me just make a table for us, because there's just a ton of words. It's hard to see it. There's brand A, and there's like fiber and protein and fat. I'm looking right here. Fiber, protein, fat, and that's for brand A. And then for brand, and that's 35, 30, and 30 for brand A. Then for brand B, it's 140, 90, and 70. 140, 90, 70. For brand C, it's 245, 150, and 120. And D, and they go on and on here. D is 420, 270, and 200. Okay, how many cases of each brand should the breeder mix to obtain a food that provides? Okay, now look at this part. Down here it says, I don't know if you can see any of those words. I can't make it bigger; it'll go off the screen. 4550 unit. I can turn the lights off. 4550 units of, is that fiber? That first one. 4550 units of fiber. So now, let me help you with this. Where am I going to put the 40? Because this will come up pretty commonly. They'll give a big old table and a bunch of numbers like this. Where am I going to put that 4550 units of fiber? I'm going to put that as a big old fiber row right here. This is the total for fiber. Everybody see how I put it there for the fiber row? And the next one is the 2850 for protein. That's the total of the protein row. And then the fat, 2250. That's the total for the fat row. Good there? Everybody see that? Okay. Okay, great. So what? So what? Well, what are my variables in this? It says right here, doesn't it? Let X represent how much brand A. So let me try to make this as easy as I can for you. That is my job. Brand A is X. They're telling me that's X. So you just go right down brand A and just go X, X, X. Those are my equations, basically. That is my matrix. Do you see it? And B, Y, is brand B. So just go Y, 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 because that's all B straight down, isn't it? And Z represents C. So Z, 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 next to the C numbers. And then D is W. So W, W, W. And equal, total means equal, right? They add up to equal the totals. That's my equation. See how the table just turns into my equations? Do you see that? And that's your matrix. Really, you don't even need the X's, Y's, and Z's, and W's. That's just your matrix. Just type it into your calculator as your matrix and hit the button. Shall we do that? So just type that in. You know, just a big old bracket. This is the bar right here. Well, you don't even have a bar in your calculator. So just put that into matrix A and then do the RREF. Remember that? This will be matrix A, and then do RREF for matrix A. Reduced row echelon form. So that's how we solve these things. Remember those steps for putting it in? So let's do that. So remember, I don't know if you remember how to do it, you had to hit second matrix on your TI calculator. Go over to edit. So you hit, I can write the steps out over here again in case you're a little rusty. Second matrix, and then go over twice to edit. Hit enter, and then put in matrix A. And then for matrix A, yeah, it's got to be what's the size of matrix A? 3 by 5. Remember, it's always down first. It's always down and then across. It's a 3 by 5. So 3, 5, you got to hit enter after each of those. And then enter matrix A. Enter that whole thing. When you're done with that, you go second, quit. You quit out of matrix A once you've got it put. It's like a word processor or something. You're storing your file. You put all the information in, and then you just close the file, and it saves it. It's got it. And then, once you're done with that part, you go back into second matrix again, and you go down to RREF, hit enter, and then a third time, second matrix, and you just, on A, you just hit enter, because you're calling it forth. And then you hit enter one more time, because that tells it to actually do what you just asked. So there's the steps. Put that in. I'll do it too. See what I get here. It's a 3x5 matrix. Feel free to check with those around you, see if you're getting the same thing. Oh, I forgot. When you use second matrix, you have to go over to math first, huh? That second time I forgot. Second matrix, go over to math and then go down to RREF. I forgot about that. So when you're doing the second time, second matrix, go over to math and then down to RREF. It's a math function on matrices. That's what you're choosing. Go into the math menu and go down to RREF and then hit second matrix again and just hit enter twice because that does it. When I did all that, here's what I got. I got 1, 0, 0, negative 1, 0. 0, 1, 0, 5, 15. 0, 0, 1, negative 1. 10? Is it 10? Yeah, it looks like 10. Y'all getting that? Okay, we good to there? Now, getting that, hopefully I understand. If not, feel free to check with those around you or grab me after. I'd be glad to help you out. So now what does that mean about, then they're saying if W equals 0, give us an answer. Now what is that? What in the world does this answer mean about like real life and what we're supposed to do in this real life word problem? Well, to figure out the meaning of any answer, any matrix, go ahead and put the letters back in there. Or just do this. How about, this is brand A. Remember what it was? A, B, C, D, and this was total. Remember? Remember all that? So that means 1 unit of brand A, or you can put the X's here as well. This was X. X is all the way down. This was Y's all the way down. You always put X's down the first column, then Y's, then Z's, then W's, and then equals. You all with me? So whenever you have an answer matrix and you're looking at it and you're thinking, what does that thing mean? Just go X's, then Y's, then Z's, then W's, then totals, what it equals. That's what the matrix is telling you. It's just pulled off the letters, put them back in. Okay, so what is this first equation saying? 1x minus 1w is 0. Isn't that what it's saying? Because the y and the z are 0, they're gone. 0 times y is gone. 0 times z is gone. So it's saying 1x minus 1w equals 0. Isn't that what it's saying? So solve for x. How do you solve for x? Jump this over. So x is w. Isn't it? Let's try the second equation. 0, 0, let's go on. 1y plus 5w is 15. See what that's saying? Jump the 5w over. Y equals 15 minus 5w. Am I losing you? You see what I'm doing there? Everybody see how I did that? I just took that first equation, 1y plus, why is that plus? Well, because there's no sign on the 5, it's plus. Plus 5w is 15. Then I'm trying to solve for x, for y, for z. I'm trying to solve for them. So get x alone, get y alone. Last line, 0, x or y gone. So 1z minus 1W is 10. Move the W over. Z equals 10 plus W, doesn't it? You good there? So I was able to take that answer matrix and turn it into an answer for X, Y, and Z. This is an infinite answers matrix, isn't it? Remember how we had the three types? One answer, infinite, and no solution. What is one answer matrix? How about if you just get one answer? What does that look like? All the ones down the diagonal. And we don't quite, yeah, I mean, of course there's numbers on the right side. We don't quite have that. We have ones down the diagonal here, but we have these extra numbers here that make it not be one answer. It's going to be infinite. All right, so where are we at now? So we have X is W. I'm just going to bring these guys down. Y is 15 minus 5W. Z is 10 plus W. Okay, now we're positioned to answer their questions. What does that mean? I mean, real life, what's that W? What does that mean? Well, coming back over here, remember this is an animal breeder, and they're having the four types of food for these pigs. How much of the brand A food, how much of the brand B, how much of the brand C, how much of the brand D food should they put in the mix for the pigs to get all the protein and fiber and fat they need? That's what we're trying to answer real life. Well, the answer is there's an infinite number of ways you can do it correctly. There's not just one right answer. There's an infinite number of ways you can mix the foods together and get the desired outcome for fiber, protein, and fat for the pigs. Well, okay, well, give me one real life answer then. Infinite. Well, what does infinite do? I need something I can do. If I'm the breeder, give me an answer here. Okay. Well, let W be 0, and you'll get one answer. Come back over here. If I let W be 0, let's put it right here. If W is 0, then what is X? Well, it's just 0. What is Y? 15 minus 5 times 0. In other words, Y is 15. What is Z? 10 plus 0. In other words, Z is 10. In other words, use 0 of brand A. 15, what are these? Pounds? What are these? Unit. A case. Oh, it's a case. Each case of brand A. So use 0 cases of brand A. Whoops. And then remember, Y is brand B. 15 cases of brand B and 10 cases of brand C. And W, what was W there? W was 0. That's case D. Remember? A was X, B was Y, C was Z, D was W. Right? In our original setup. So that's one real life answer. Here's what you could do for the pigs. No cases of A, 15 of B, 10 of C, and none of D. If you mix that in and give it to them, they'll get the fat, protein, and fiber they need. Or, remember there's infinite answers here. Another possible answer is to let W be 1. That's what it's doing here. It's saying let W be 0 and give us the answer. See, 0, 15, 10, 0. 0, 15, 10, 0. You see them? 0, 15, 10, 0. That's an answer. That's one particular answer. There's an infinite number of answers. That's one particular formula for feeding the pigs. No A, right? This means no brand A, no A, 15B, 10C, no D. That's one formula that will feed the pigs all they need. But that's not the only one. There's infinite answers here. Let's go on to W equals 1. You could let W be 1. You see, all these answers, X, Y, and Z depend upon W, don't they? They're going to be different things depending on what you choose for W. W is the variable. So now they're saying, let W be 1 and tell me what you get. Okay, X, put in 1 now, 1 now, 1 now. X will just be 1. Y will be 15 minus 5 times 1. So Y will be, what's that, 10. And Z will be 10 plus W. W is 1. So Z will be 11. And again, let's put W at the bottom. W that led to all this was 1. So that's how much A, how much B, how much C, and how much D. That's another formula for feeding the pigs that'll make them have all the right fiber, protein, and fat. 1 case of A, 10 of B, 11 of C, and 1 of D. If you mix that in, they'll get the right amount of fiber, protein, and fat. Except there's an infinite number of different, depending on what you choose. See how we can just keep going with this? We can choose W2. then there'd be a whole other set of answers. W3, whole other set of answers. Just keeps going and going. There's different ways you can mix the food and have it all come out right. There's not just one way. That's pretty much like real life, isn't it? Is that good? Do y'all see how we solved that? Questions I can answer? So this is the only one. Make sure you know it well. I do like to put this kind of thing on the test where you have to choose a W and pick out the different options. It's very real life. I think they have you do W equals 1 and then W equals 2. I think they have you do one more with W equals 2. And then find out the numbers again. I'll move on. We good? All right. Okay. So, wish I could make it a little bigger. Sorry, but it'll go off the screen. I'll read it here. The controller, the money manager for a small company, puts some money in a bank account that pays 3% per year. He uses some additional money, amounting to 1/3 the amount placed in the bank, to buy bonds paying 4% per year. With the balance of the funds, he buys a 9% certificate of deposit. The first year the investments bring a return of $670. The total of the investments is $10,000. How much is invested at each rate? That sounds complex, but these investment ones are the same every time. Let me show you. Basically, the first thing to do when you read these big old word problems, let me help you. There's really just a couple of steps, and if you get these steps down, it's kind of the same every time. First thing is always to identify the variables. What are my letters? Well, you know that because that's what they're asking for. Whatever they ask for, that's your variables. So what are they asking for? Bank account, bonds, CD. So I'll just call it bank account. Well, why don't I just do X, Y, Z, I guess. So X, Y, Z. And it'll be bank account, bonds, and CD. Is that good so far? Okay, so let's give it a try here. The controller for a small company puts some money in a bank account paying 3%. Now, one of the equations is going to be the invested amount. The next is going to be the interest or the earnings, however you want to think of that. And then the third one's going to be special. That's every time in these money ones. There's going to be one where they just like total money, total of all these monies that you put in. The second one's going to be the interest. That's where you multiply by the percentage of the accounts. And the third one's going to be special, where they go, oh, this is double that, or this is 1/3 of this, some special thing. Because we know we need 3 equations, right? 3 letters, 3 equations. We good? And it doesn't matter what order you put those in. You can switch these up. It doesn't matter what order. Here we go. Invested. Where do they tell me total investment? Do you see it right here? Total investment, $10,000. That means they took $10,000 and they put some of it in X, the bank, some of it in the bonds, and some of it in the CDs. So X plus Y plus Z is 10,000. We always have no percentages, nothing else, just like that. Now the next equation, the interest, that's where we'll bring in the percentages. So what's for the bank, what's the percentage for the bank? The bank, 3%, 0.03x. Good so far? Because this is going to be interest, right? How do you figure out how much you earn? Well, it's the percentage. If you put, $1,000 in the bank and they're paying you 3%, it's 3% times 1,000, isn't it? So that's where the percentages come in. Okay, the Y. Well, the Y is the bonds. What does it say about bonds? Bonds, 4%. And then the Z is the CDs. The CDs are right here. Is it 9 or 5? What does it say? Whoops, can't read. It didn't help. 9, right? 0.09. 9% for Z. And what's the total amount of money they made? Right there, 670. Is that making sense so far? They always have those 2 equations. Notice, one of them is just X plus Y plus Z total. No percentages. The other one is the percentages and the investment, interest, return, whatever they want to call it, money they made. And then the third one is going to be special. And that's, what other words have I not used? What other words up there have I not done anything with yet? That's the only thing I haven't done yet. Here, all the percentages are used, all the other numbers are used. Some additionally, he uses some amount of money, 1/3 of the amount placed in the bank, to buy bonds. Is that a confusing sentence? That's a way of saying bonds is 1/3 of bank. Do you see that they're saying that? He uses some money, 1/3 the amount in the bank, 1/3 of the bank, to buy bonds. Bonds is 1/3 of bank, they're saying. The amount put in bonds, it's 1/3 of the amount put in the bank. Do you see that they're saying that? Bonds is 1/3 of the bank. Bonds is 1/3 of the bank. So how do I write that? Bonds, which letter is bonds? Y. Bonds is Y. Y is equals, right? 1/3 of is times. Do you guys know of is always times in math? 1/3 of something is 1/3 times something. Of is times. 1/3 of bank. What's bank? X. Y is 1/3 X. Y equals 1/3 X. Well, here, let me put it over here. We're going to need to clean it up a little bit. Y equals 1/3 X. And then I'll put it down here after it's cleaned up. What do we have to do to clean it up? Well, we have to put it into a matrix. We're going to stick all this into our calculator in a matrix in a minute, right? To get it formed up for matrix, we're going to have the X, Y's, and Z's on the left, numbers on the right, don't we? So I've got to take this equation, Y equals 1/3 X, and I got to jump the 1/3 X over here. So it becomes minus 1/3 X plus Y equals 0. Everybody see that? How it came down that way? See what I did there? Is that good? Y equals 1/3 X. Y equals 1/3 X. Bonds is, now that's the hard part. It's getting used to reading those special equations. That's the part that's going to change up from problem to problem. That's the tricky part. That's the curveball that you got to get ready for. The rest is just pretty predictable. Straight ahead, straight ahead, straight ahead. So then we just type that into our calculator, right?
Why is it negative 1/3?
Because I had to jump the 1/3 to the other side. Whenever something jumps to the other side, it changes signs. I really subtracted 1/3 X from both sides.
Oh, okay.
Is what I did, if that's helpful, to make it 0 on the right side. Yeah, because why did I do that? Because I have to get the form for our calculator. So we have to have X's and Y's and Z's on the left side. We have to have numbers on the right. So I couldn't have the X on the right side. I had to subtract 1/3 X from both sides. That made it negative 1/3 X on the left. Left me 0 on the right. Is that good? So that's, now you just type that into your calculator. You guys want to do this one? There's a 0 here. You know that these are 1s, huh? These are 1s. This is a 1. 0, 0, Z here. And so just put that thing in. That's matrix A. And hit RREF. And you'll get the answers. So type that into matrix A. Go over to edit. And that one's a 3x4. Isn't that one a 3x4? 3x4 matrix. Down 3 over 4. It's a 3x4. And for the 1/3, just type in -1 divided by 3. Just make -1 divided by 3. Right there. Then quit that, go back to second matrix, go over to math and down to RREF for A, and boom. I'm getting some answers. What number was this? This was question number 6. Here's it. I'm getting this matrix. 1, 0, 0. I'm getting the diagonal ones, which means there's only one answer. One set of answers, I should say. Right, when you when you get this diagonal and then just the right side, that means that's the one set of correct answers. So this is X, this is Y, this is Z. 3,000 in the first account, 1,000 in the next, 6,000 in the last. Y'all getting that? On the calculator, is that working out? 316. See how we did that? And again, the order doesn't matter. If you put the special one at the top or whatever, it doesn't matter. It'd come out the same. Doesn't matter how you do that. Questions I can answer. Okay. Blah, blah, blah. You don't need to read those words. Well, maybe you do. Yeah, I guess you do. The table on the right shows the calories, sodium, and protein in 1 cup of various kinds of soup. How many cups of each kind of soup should be mixed together to produce 10 servings of soup? Each of which provides, what is the serving size? I'm confused. Why are they talking about serving sizes and cups? I think I remember that. I don't like this problem now. They do something funny with serving sizes and cups. How many cups of each? What is the serving size in cups? What are they talking about? Do you guys understand that? Let me go. All right, so here's what we're doing. So it does have a little bit of a wrinkle, a little trick here. So basically, this is my matrix right here. This is my matrix. Except the only thing, see how it says 1308 sodium? Wait, oh yeah, I forgot over here. Calories, 219 calories, so this would be 219 calories. This is the calorie row. And the next one is 1308 for sodium. And the third one is 13.6 for protein. Good there? Are y'all with me? Is that good so far? I'm just grabbing their numbers. That's the amount. But careful, that's the amount they want 10 servings. Each has 219. So that means you got to multiply each of these by 10. 2190, 13080, and 136. Yeah, because these numbers were for one serving, right? 10 servings of each gives 219. So if you want 10 servings, you got to multiply 219 times 10. So they really want you to produce those numbers. That's the right side of the matrix. Is that good? So put that put that matrix in 100, 130, 120, 2190. 780, 670, 610, 13080. All right, can you put that into do the RREF on that matrix? I'll do it with you. Let's put that thing in. So what, a 3 by 4 again? Go down to quit, second matrix, go over to math, down to REF, go Go into second matrix. Hit enter, enter. So here is what I got. I got the following results when I did RREF. Oops. I got the diagonal matrix. 7, 5, 7. So that's my one unique answer, right? I'm not getting infinite answers anymore. This is one unique answer. You guys getting that okay? 757, is that coming out? With the RREF. If you have trouble with that, grab me after. Okay, now, here's the trick right at the end. They want you to say, okay, how many cups? So that's 7 cups of chicken noodle, 5 cups of chicken and rice, 7 cups of chicken rotini. That's the answer to the question, 757. But there's one part remaining. Their final question to us is going to be, what is the serving size in cups? Well, how do we figure that out? Well, how many cups? These are cups, right? How do we know? The table on the right shows the calories, blah, 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 for 1 cup. All of these are for 1 cup. So when we're done, these are cups. So we have 7 plus 5 plus 7, which is 19 cups. 19 total cups of soup will produce all these servings. Are you with me? Am I losing you? They want me to go serving size. So it's 19 cups for 10 servings. Why 10? Right there. That's what's tricky on this one. This one's a little tricky right there at the end. Honestly, I'm not going to give you one quite this tricky on the exam. This is tricky where they're playing with the cups and the servings. So when they ask serving size in the end, they want how many cups per serving. That's what serving size is, right? How many cups per serving? So cups per, or let me put it up here. Cups per serving is cups divided by servings. It's 19 cups for 10 servings. 19 cups for 10 servings, that's 1.9. If you divide that in your calculator, 1.9 cups per serving. See, I know that's tricky at the end there. So at the very end, I just added these up, said, well, there's a total of 19 cups to make this thing happen, and this thing is 10 servings. So that's 19 cups per 10 servings. Divide that out, that's 1.9 cups per serving. Let's go make sure that answer's right. Are we all good with that? Any questions I can answer on that one? So again, I'm not going to put on the test the whole cups and servings, and then I'll just give you, I would give you this problem, but I wouldn't play games with the cups and the servings. I would just put the basic information and say, give me the 757 answer. That's all I would want. And you wouldn't have to do the trick with the multiply by 10. I won't do that. All right, that one had a couple tricks. All right, last one. Here we go. Investment firm recommends that a client invest in bonds rated AAA, single A, and B. The average yield in AAA is 5%. A is 7%. B is 12%. Client wants to invest twice as much AAA bonds as B bonds. How much should we invest each type? Under the following conditions. The total investment is $9,000. The investor wants an annual return of $650 on 3 investments. All right, let's do part A. Pretty standard. Pretty standard. 9,000 investment. Return of $650. See what you can do. This is pretty standard one. Give you a little bit of time. In fact, I'll even wander around. Let me wander around. If I can be of help to you, let me know. Can y'all read that? I just can't make it any bigger and go off the screen. They made it so wide. So 3 letters. See if you can write your 3 equations. I'll wander around, see if I can be of any help. Feel free to chuck with those around you. Get as much as we can out of this hour and 15 minutes we have together. Guess this is easier than a calculus? Not easier. Not necessarily.
I think this is more word problems than calculus.
That's true. That's true. Okay, there's a lot of X's moving around. Oh, I see. Good idea, good idea. 650 with 2 zeros, yeah. What percentages? They are, yeah, 5, 7, 12, right. Good, and what's this now? So that's twice as much in AAA as B. That's twice as much as 2 C's. Yeah, good job. Good job. That's exactly right. Yeah, nice. Nice. Oh, 4, 3, 2? Good. So the answer should be 4,000, 3,000, 2,000. See if you can get that in your calculator. 4, 3, 2. Good.
Oh, it's 12.
It's hard to see those, yeah. Yeah, good.
So is this one doing twice the investment? Would that be twice the percentage rates?
That's a whole separate equation. Yeah, you don't mess with the percentage rate at all.
Oh.
Yeah, so that twice thing is the special equation, right? The third equation, it has nothing to do with the other equations. Don't bring in the percentages or anything like that. I remember what we talked about with the special equation. If they say, hey, one thing is bigger, you got to bring up the small guy, right? If I say, hey, this other thing is twice as big, if you want to write them equal, want to make an equation, then you got to bring up the small guy. You got to double the small guy, don't you? To make them equal, which is what we're trying to do. We're trying to write an equation, trying to make them equal. No, sorry. Yeah. And I wish I could blow it up so you can all see, but I guess I could write some facts out. So so AAA is 5%, regular A is 7, and B is 12. Like that. And twice as much in AAA as B. That's the special equation. See if you can write that. Remember, you got to double the small guy to make them equal, don't you? And then then what does it say? Oh, total invested is, was that 9,000? And return is, was that, is it 650? 650, yeah. So there's the crucial facts. See if you can turn those facts into 3 equations or a big old matrix, and then solve it. And solve your matrix. Should be, the answer should be 4,000, 3,000, 2,000. See if you can get that. Give you another little bit here. I think you'll get more out of it just to get one here before we go. The next section's super easy. So it's best to use our time here. Try that. If I can help. If you're having trouble getting stuck on this thing. I turn the other light on so you can all see well too. Now that you can see that, right? I wrote them bigger and everything. We can maybe see your own papers better too. So write 3 equations or 3 things for the matrix on that. Yeah. Sure.
That's right.
Oh, I see. See,
And I just added these two together, so x would be 0, this one would be 0.07, and this one would be 0.22.
yeah,
Z.
yeah.
And then
You're doing a good job. That'll totally work great. Whenever you do that, you're actually using another equation. That's great. That's great. But you really are using 3. When you did that little substitution right there,
Yeah.
that was because you knew of another.
Yeah, because it's
Fact.
twice.
Yeah, that's great. No, you're doing great. That's just another way of doing it. Yeah, that's good. So you guys getting those okay? This making sense on these? This one, these have to be swapped. Let's see if I can do 9,000 because the percentages go with the return. Okay, so on these ones, so the percentages, so the 0.05, the 0.07, the 0.12, they always go with the return because that's what gives you return on your money, right? Is a percentage of your money, and you can put that one first, second. It doesn't matter what order you do these in. So one of them is going to be the return, and the return one has the percentage. The other one is going to be the total invested. That's just going to be 1, 1, 1, and 9,000. Because you see why that is? Because that's 1x plus 1y plus 1z is 9,000. That's just x plus y plus z is 9,000. The other one is, x, y, z, 650. You don't have to put in the letters. And then, now the tricky one, is everybody good with that though? Those two are always the same in these money problems. There's always one of them that's just X, Y, Z, total invested. Every time. And then the percentages go with the return or the interest or whatever they want to call it. And now the third one is special. That's where the curveball is. They can kind of change that up on you. Twice as much, and that's X, and this is Z, huh? B is, because it's X, Y, and Z for the AAA, the A, and the B, are X, Y, Z. So twice as much in AAA, X, as B. X is twice as much. Well, if X is the big guy, and you want to bring equality, you want to make them equal, then you got to double the little guy, don't you? So X is 2Z. Does that make sense? You got to double the Z to make them equal, because we're trying to make them equal, trying to establish equality. So we got to double the little guy. We got to double the Z. Is that good there? But then we can't leave it like this, huh? We have to put it, we have to have X, Y's, and Z's on the left, numbers on the right for our calculator, to type it into our calculator for the matrix. So that means you just jump the 2Z. What happens when something jumps to the other side of an equation? Signs in front of it change. So that'll become X, whoops, moving on me here, X minus 2Z, and there's nothing left on the right side, so it's just 0. And there's also a 0 in the Y slot, huh? Because there's no Y. Everybody see the numbers then? This is 1, 0, negative 2, and then 0 over there. Is that good? Does everybody see how that worked? And then just put that in your calculator. Just put that matrix in and hit RREF. What was the answer? Wasn't it 4,000, 3,000, 2,000? That was for RREF. So it's just 0.05, 0.07, 0.12, 650, 1, 1, 1, 9,000, and 1, 0, negative 20. Typed into your calculator. RREF. On that. Is that okay? Can I leave that behind? Got to do a little bit on the next section. I'll finish it. It'll be super easy. Let's stop.